The sine rule, harder problem number 2. Okay, in this one we're given that the exact value of sine 15 degrees is root 6 minus root 2 on 4. And we have to show the exact length of AC is 10 outside of root 3 plus 1. Before we can start this, we need to get a bit of information on that triangle ABC, because we're going to use the sine rule. Now we know that the exterior angle of a triangle is equal to the sum of the two interior opposite angles. So this angle up the top here, excuse me, must be 15 degrees. Right then, 15 degrees up there. Alright. 15 plus 45 is 60. Alright. Now we're set to go. We've got to find AC. So AC over the sine of 45 is equal to 10, which we're given, over the sine of 15, which is this root 6 minus root 2 on 4. Okay. So this is 1 on root 2, so that's AC root 2, inverting and multiplying, gives me 40 over square root of 6 minus the square root of 2. So it's very similar to the first problem I gave you. Rationalising, we get root 6 plus root 2 over root 6 plus root 2. Okay. Now that becomes 40 outside of root 6 plus root 2 all over 6 minus 2, 4. So this becomes 10 outside of root 6 plus root 2. Now, if AC must be equal to, dividing both sides by root 2, maybe with a space there, 10 over root 2 into root 6 plus root 2. And now I'm going to rationalise root 2 times over root 2. That becomes 10 root 2 on 2 into root 6 plus root 2. Okay, so almost there. That's 5 root 2 outside of root 6 plus root 2. Taking the root 2 inside, we get 5 outside of root 12 plus 2. Again, simplifying the 12, we get 2 root 3 plus 2. And taking the 2 back outside, we get 10 outside of root 3 plus 1. And that gives us the length of AC. The second part is to find the exact length of AD. Right, so we can see we've got a right angle triangle there. So we can see that AD over AC, is equal to the sine of 60. So AD is equal to, well, AC is, just worked it out, 10 outside of root 3 plus 1, times sine 60 is root 3 over 2. Now simplifying that, that becomes 5 root 3 outside of root 3 plus 1. And I'll stick that root 3 inside, becomes 5 outside of 3 plus root 3. Or if you want to, you can keep that, reverse that, and write that as 5 outside of root 3 plus 3. And that's the exact length of AD. Finally, find the exact area of ABD. Well, this is actually simpler than what it seems. Because this is 45 degrees, and this is a right angle here, this must be an isosceles right angle triangle. So we know that this AD must equal BD. So just using that simple rule for the area of a triangle, the area is half the base, which is the same as the height. So it'll be 5 squared times root 3 times 3 all squared. This becomes 25 over 2. Now root 3 squared is 3, plus twice the product, that's going to be 6 root 3. Looks like a times there, it's a plus, sorry. It's a plus in there. And this will be a 9. You square it. And that becomes 25 over 2 into 9 plus, sorry, 12. Rub that out. Just be careful. I've been concentrating for a while. You can make silly mistakes like that. Okay. That becomes 12 plus root 6 root 3. Almost did it again. Okay. Now, we take out the 6 as a common factor. And 2 into 6 is 3. And 3 times 3 is 75. Remember, so I took 6 out, so it'll be 2 plus root 3. Or if you want to reverse it, 75 outside of root 3 plus 2 units squared. There we go. Now, as I said before, this is a harder one. If you want to see more questions, go to my website at harderhscmaths.com. I'll just write that down if you didn't see the first video. That's harderhscmaths.com. HSC stands for Higher School Certificate in New South Wales, Australia. All right, okay, well, thank you for watching. I hope that was of some help. By the way, these sorts of questions are modelled on the high school certificate questions given to Year 12 students in their final examination. Okay.